Activity 2, basic exponential function y equals c to the power of x. Consider the function y is equal to the power of x and the other function y is equal to 1/2 to the power of x, where x is a member of the real numbers. Okay, for each function, complete the table of values. When x is -2, we have 2 to the power of -2. Now remember the negative exponent, it takes the reciprocal. So we're going to get 2 to the 2, which is 4, but we have the reciprocal of that, so it's 1/4. Like this, 1/4. Now if you're not sure about that, you can use your calculator. So we have 2 to the power of, and then I'm going to put 2 with a negative. So I can hit that negative plus negative e button like that. So that gives us 2 to the -2, which is going to give us 0.25, 0.25, which is 1/4. Okay, if you weren't sure, you can always double check it on the calculator. All right, so 2 to the -1 is going to be the reciprocal of 2, 1/2. All right, then 2 to the 0, anything to the power 0 except for 0 to the power 0. Anything to the power 0 is 1. And then 2 to the power 1, we just have 1, 2 standing around, so it's just 2. 2 to the power 2, that's 2 times 2 is 4, right, or 2 times itself. That's what power 2 means. Power 3 means times itself, like 3 times, like 2 times 2 times 2. We have 3 2's multiplying each other, so that's 8. Now here, we have y equals 1/2 to the x. So this is like the reciprocal of this, right, the inverse of this. So watch what happens. So if I have 1/2 to a negative, that makes it 2 to the power of 2, right? So that negative tells us to flip the 1/2. So we have 2 to the power of 2, which is 4. And if you're not sure about that, you can go and try it out in your calculator. So if I have 1/2, which I'm going to do exactly what they have in brackets. So I'm going to make bracket 1 divided by 2. Close the bracket, which is 0.5. To the power of -2. Power of 2 negative equals. Okay, and I'm saying it's going to be 4. And look, it is. So there you go. All right, so then we have 1/2 to the -1. That means just reciprocal of 1/2, which is going to give us 2. Okay, and then anything to the power 0 is 1. And then 1/2 to the power 1, just have 1/2 hanging around. And 1/2 to the power 2 means a half times a half, which is going to be a quarter. 1/2 to the power 3 is 1/2 times 1/2 times 1/2, which is going to give us 1/8. Okay, if you're not sure, you can double check any of these on the calculator. B, represent each function on the Cartesian plane. So here's our Cartesian plane. And when x is -2, so this is the x-axis, when x is -2, y is equal to 1/4. So that's a half. Half of a half is a quarter, so about there. Okay, up. And then when x is -1, we get 1/2, which is right here. And then when x is equal to 0, we get 1, which is here. When x is 1, we get 2. When x is 2, we get 4, which is right there. When x is 3, we're going to get 8, like that. Okay? And then I'm just going to connect these dots with a nice curve that kind of fits them best. All right? Notice it gets closer and closer and closer to the x-axis, but never touches. All right? We'll discuss that in a second. All right, the next one. When x is -2, the y value is 4. So when x is -2, the y value is 4 right there. When x is -1, the y value is 2 right here. Notice it's like the mirror image of what I have over here. When x is equal to 0, y is equal to 1, like that. When x is equal to 1, y is equal to 1/2. So here's 1/2 right there. When x is equal to 2, y is equal to a quarter, which is a half of a half. Okay, when x is equal to 3, y is equal to 1/8, which is a half of a quarter. So it's like really close to the x-axis, but not quite touching. Okay, and then I'm going to make a curve that kind of fits all those like that. All right, and notice they're like the mirror image of each other. Like it's a reflection across the y-axis. Very interesting. So we observe that each of the curves representing these functions gets closer to the x-axis without ever touching it. Okay, that means that the x-axis is an asymptote. We say that the x-axis is an asymptote for the curve, or the curve is asymptotic to the x-axis. And that's it for activity 2. Have a good day.